Welcome. My name is Till Wagner. I'm a assistant professor in physical oceanography at the University of North Carolina, Wilmington. And it is my great pleasure to talk to you today about the rapid observed sea ice loss in the Arctic over the last half century or so. Before I start looking at sea ice in detail, I wanted to provide some background about the difference between land ice versus sea ice. So on the left here, we have a map of the southern hemisphere with Antarctica at the center. And on the right, we have a map of the Arctic Basin, located at the center of the northern hemisphere. So in the modern day climate, there are two major land ice sheets. An ice sheet is a large body of land ice, and we have the Antarctic ice sheet on the left and the Greenland ice sheet on the right. Now, land ice is formed by falling snow that compresses over hundreds of thousands of years and turns into ice and creates these large bodies of ice. And they can be up to 4 kilometers thick in the modern day climates. Now, the Antarctic continent is surrounded by the Southern Ocean, and in the winter that ocean freezes over and gets covered by a thin layer of sea ice. So sea ice is just the frozen top of the ocean, and it is much thinner than the land ice. It's typically 1 to 2 meters thick, if that. The same is occurring in the Arctic. The Arctic basin is covered partially all year round in sea ice, and in the winter the sea ice extends to the peripheral seas as well. So the main point of this slide for me here is that land ice, which sits on land, when that melts, it contributes to sea level rise because you're adding a new volume of water to the existing ocean. Whereas sea ice, on the other hand, is already floating in the ocean. And when sea ice melts, you're not adding any new mass to the ocean. And so sea ice is actually not contributing to sea level rise. So why do we care about sea ice? Well, I'll get back to that in a minute. But first, I wanted to give a little bit more detail on the Arctic sea ice seasonal cycle. So here I have a visualization from the NASA Scientific Visualization Studio. And what we are looking at here is the Arctic sea ice cover as it grows in the winter to extend to low latitudes and then melts back every summer. So in the winter, it grows to up to 16 million square kilometers, and then it shrinks back every summer to something between 6 and 4 million square kilometers. If we plot the area as a function of the day of the year, that's what I've done here, you will see the seasonal cycle. Every curve here corresponds to 1 year. And we've been doing this since the beginning of the satellite era in 1979. So every year we have a maximum sea ice extent at the end of winter in March, and then at the end of summer in mid-September we have a minimum. If I color these curves by the year taken, then you will see a very interesting pattern. The bright beige here is the early years, the earliest being 1979, and the latest one here is 2019. And you can see that over the years, sea ice has become less and less. And this is most pronounced in the September minimum. So I wanted to focus here on the evolution of the September minimum. If we're looking at all these measurements and plot them, the area as a function of the year, you're finding this steady decrease. There's some natural variability between years, which is kind of like the differences in cold winters that we experience and warm winters. But overall, you see that we have started in 1979 with close to 8 million square kilometers of sea ice area in September. And nowadays, we have something closer to 4 million square kilometers. So in 79, the ice cover looked roughly like this in September. and in the summer of 2019, there was only about 60% of this left. So over the last 40 years, we have every decade, lost about 10% of the original ice cover. Now, you might wonder, how accurate are these measurements, and how do we even know all of this? And the broader question is actually, how do we carry out Arctic science? And so that's what I wanted to talk about next. These data that I've just shown you are all collected using satellites. Satellites have become extremely sophisticated and are very good at measuring the areal extent of sea ice. So the data that I've just shown you, we know with a high degree of certainty. Satellites are not as good at measuring the thickness of sea ice. So if we try, for example, to compute the volume of sea ice, our estimates have a much higher uncertainty than for just the area. And also, satellites are limited. They don't tell us much about the ocean underneath the ice. They don't tell us really much about the conditions of the ice itself. So we also have a second pillar of Arctic research, which is field observations. We go to the Arctic to take measurements of the ice itself, of the ocean underneath the ice. Here I'm in Fram Strait with some students. We're extracting ice cores to look at salinity of the ice, at ice age, and also at the biology in the ice and underneath the ice. Satellite measurements and field observations are really good for us to study the past and the present of the sea ice. But we also are interested in what the future is going to look like. And for that, scientists develop ice and climate models. These are typically computer simulations that are fed with current data and obey the laws of physics and project out what the sea ice is going to look like over the coming decades, centuries, etc. Now, why do we care? Since I just told you that sea ice is not actually that important for sea level rise, but it nevertheless plays a hugely important role in the climate system. So, first of all, sea ice is very reflective. It is white and it reflects a lot of the incoming solar radiation. You can imagine if you remove the sea ice from the Arctic Ocean and replaced it with open water, it's a little bit like taking a white t-shirt off and putting a black t-shirt on. You're going to absorb a lot more of the incoming heat. And that has far-reaching implications for the local and for the global climate. Sea ice also, when it grows, produces dense water. And that dense water sinks to the bottom of the ocean and helps drive the global ocean circulation. And then one more thing, it obviously keeps the Arctic air temperatures cold as well. So that in itself has important implications for atmospheric dynamics. Beyond the climate system, the Arctic is increasingly receiving attention from humans. And that is because if you remove the sea ice, you are suddenly left with a new open ocean. So here I'm showing a map that was printed in the New York Times a few years ago that shows potential shipping routes between 2015 and 2030 from Europe and North America to Asia. The green routes that you see here are shipping routes where cargo ships could be traveling without the accompaniment of icebreakers. The red shipping routes would still need icebreakers. But up to very recently, it was kind of unthinkable that you would take cargo through the Arctic. But obviously that would be extremely interesting if you didn't have to go the southern routes anymore. Beyond shipping and transport, tourism is increasing, exploding in the Arctic basin. And obviously there is a lot of interest in exploring oil and natural gas extraction in the area, which comes with its own set of promises and risks. And related to that, And in general, very important is the impact of sea ice on the Arctic ecosystem. So, as we all know, the Arctic ecosystem, especially the charismatic megafauna, polar bears and walruses, depend on the sea ice as their natural habitat, as their hunting grounds. But beyond that, the sea ice is also really important, for example, for spring blooms of algae, where the meltwater helps drive these blooms. And the formation of dense bottom water also drives upwelling, which provides nutrient-rich waters from underneath, which in turn also is a crucial component for the Arctic ecosystem. So the sea ice is important, to sum up, for the physics of the climate system, for human interests, and for the local ecosystem. So to finish up with, what can you do about it? What can we all do about sea ice loss and the challenges it presents for the global oceans? And this is always a tricky question, because the Arctic is somewhat of an abstract concept, and the dynamics and sea ice is a phenomenon that are occurring in a very remote place. And so for me, I've always found that learning and teaching about the polar regions and their importance for the global oceans is one of the best ways that we can help raise awareness and protect. So I've chosen to show a picture here of a workshop that I led with middle school girls as part of the Better Education for Women in Science and Engineering program. And I can just encourage all of you to try and learn and teach our next generation of scientists and citizens to appreciate the importance of sea ice in the Arctic and its importance for the global climate system. Thank you very much.